Hi everyone, this is the second video covering 15A, so part 2. We're going to look at an example on conditional probability and then do quite a few questions from 15A. So it's important that you pause if you feel like you can do it on your own, or have a go at doing it on your own and then watch it and see how you went. This example here is actually done as a video on the textbook, so I'm going to be sneaky and let the lovely lady do it for us.
In this particular problem, we are told that the time that a student takes to complete a given puzzle is a random variable that follows the density function given by this rule here. So to find the probability that a student takes less than 12 seconds, what we're really wanting to do is find the integral of this function between the lowest x value and 12. Now the lowest x value that we have in this function is 5. Which means that all students are taking at least 5 seconds to complete the puzzle. So the probability that a student takes less than 12 seconds means that they are taking between 5 and 12 seconds to complete the puzzle. So we're going to integrate this function between 5 and 12. So in order to do that, I'm going to increase my power by 1 and divide through by the new power. Then we substitute 12 into this formula and then subtract, sub in 5 into this formula. Work that one through and we end up with an answer of 7 on 12. The probability that a student takes between 8 and 10 seconds to complete the problem, given that they take less than 12 seconds, well, we're going to use our conditional probability formula to help us evaluate this. So to do that, we're going to look at the probability of A intersection B over the probability of B. Now to work out where these two guys intersect, it helps to draw up a number line. If we're looking at x being between 8 and 10, we're looking at these numbers in here. If we're looking at a number that is less than 12, we are looking at these numbers here. So where these two orange lines overlap, you can see it is between 8 and 10. So to evaluate the probability that x is between 8 and 10, we need to integrate f of x between the terminals 8 and 10. And that's going to be all divided by the probability that x is less than 12, which we worked out in A is really the integral between 5 and 12, because all students take at least 5 seconds. So on the numerator there, we end up with the integral of f of x, which we worked out in part A to be negative 5 on x between the terminals 8 and 10, divided by 7 over 12, which we worked out in part A. To evaluate the numerator, we're going to end up with negative 5 over 10, subtract negative 5 over 8, all divided by 7 on 12. And when we work that one through, we end up with an answer of 3 on 14.
All right, so let's return to the notes. So you can see all the working there as well, but in that video, just explaining how the question is answered, and we're using definite integrals again. So I'm going to go past this. That's just the section summary, what we've already covered. Okay, so just remember, if we're looking at the probability between two values, we just use a definite integral. If we're looking at the probability between, say, a value and infinity, we've got to introduce limits. So that's the third dot point here. So just keep that in mind. All right, so let's do some questions together. So question 5, the quarantine period for a certain disease between 5 and 11 days. Sorry. Let's start again. I didn't read that. I missed a word and it totally didn't make sense. The quarantine period for a certain disease is between 5 and 11 days after contact. The probability of showing the first symptoms at various times during the quarantine period is described by the probability density function. All right, so sketch the graph of the function. So we're going to just do that on the calculator. You could do this one quite easily by hand because it's just a quadratic. You can see that it's been factorized, so that's easy to find your x-intercepts. So your x-intercepts are going to be at 5 and 11. And then you can just find the turning point by doing the halfway between that. But we've covered how to sketch quadratics before, so I'm just going to do it on the calculator. All right, so we'll go to menu, graph. All right, let's just clear what we had before. and put in what we have here. So 1 on 36 times, and put x, not t, so x minus 5, 11 minus x. All right, and just tick it, and then we can, and we only want to go from 5 to 11, so we can restrict it. We can find the button. All right, so we're going from 5 to 11. All right, so let's sketch it. Now, if you can't see it, we just go to Zoom Auto. Oh, still can't see it. Just give me a sec while I figure out why I can't see it. All right, so there we can see the graph, probably very hard graph to actually play around with the zoom function. But your knowledge of quadratics, you should know that your x-intercepts are 5 and 11. If you want to know this turning point, it's just halfway between 5 and 11. So add them together, divide by 2. So 5 plus 11, 16. So your turning point is at x equals 8. But you could also just go to, let me just find it on here. We want the maximum. All right, and it's found it for us. So x equals 8 and y equals 1/4. So when you're sketching it, you really do need to put those two endpoints, your x-intercept and your two x-intercepts and the turning point. All right, find the probability that the symptoms appear within 7 days. Just give me a sec to get myself organized. So I'll quickly sketch A. It's not going to take too long to do. All right, so we're going from 5 to 11, and this point here is 8, 1/4. All right, so for question B, the symptoms appear in 7 days. All right, so our definite integral, so they have to be within 7 days, so the upper limit is 7, and then your lower limit, just think of the context of the problem. So they don't appear until 5 days, so they have to appear somewhere between the 5th and the 7th day. Then we've got our function, so 1 on 36, t minus 5, 11 minus t dt. Now you could go ahead and do the antiderivative of that, but I'm just going to do it on the calculator. So just make sure you can do that by hand. I would expand that first and then find the antiderivative. But just to keep this video short, I'm going to just do the antiderivative on the calculator. All right, so we're going from 5 to 7. And then put in the function. And if you wanted to, you could have defined it. So maybe I should have defined it. Okay. And you can do t or x. Just keep in mind, if you do change from t to x, that you do put the correct answer in. All right, so that is find the probability that the symptoms appear within 7 days. So we'll do that to 4 decimal places. So 2593. All right, so that's the probability they'll appear within 7 days. Find the probability that the symptoms appear within 7 days, given that they appear after 5.5 days. All right, so this is a conditional probability. Remember, you're looking for the phrase given that for conditional probability. So let's just set that up. Oh, we don't have much space left. It's okay. So we want to find the probability that the symptoms appear within 7 days. X is less than 7. And given that they appear after 5.5 days. Oops. And then that's over our second condition. All right, so if we're writing out the conditional probability formula, and just because I don't have much, oh, actually I'll do it. Sorry. So we want the probability that x is less than 7 and x is greater than 5.5 over the probability that x is greater than 5.5. All right, so looking at your intervals, so if I've got a number line, so 5, 6, 7, 8. All right, so my first condition is x is less than 7. And then the second one is x is greater than 5.5. Okay, so what we have in common for the first one is 5.5 to 7. So we're going to do from 5.5 to 7 of our function. So I'm just going to write f of t dt over the probability that x is greater than 5.5. So we're going from 5.5 and the maximum is 11 ft dt. And we'll just do that on the calculator. All right, so I'll just move the calculator over so we can see both screens. Now, I'm just going to, it is a fraction, so I'm just putting the fraction in and then the definite integral. Okay, so we're going from 5.5 to 7. Now, if you already defined dt, you can do that again, but I'm just going to copy and paste it. And on the bottom, we're going from 5.5 to 11. And I'm going to paste it again. Nope. And then dt. All right, so we get 0.2444. All right, so for part C, I can just bring this one down a little bit. I want that to move. Doesn't matter. Okay, so for question D, find the probability that the symptoms appear within 7 days given that they appear within 10 days. So I'm going to just set up the conditional probability for you and then you can just go ahead and do it on your calculator. So we want the probability, let's do a line here so we don't get mixed up. So we want the probability that the symptoms appear within 7 days. So they've got to be within 7 days, so x is less than 7, given that they appear within 10 days, so x is less than 10. All right, so you can substitute that into the conditional probability formula. So effectively what you're going to end up with is what they have in common is from 7 to 10. All right, and then we've got f of t dt over the second condition, the condition is x is less than 10, so it's got to be between, 5 and 10 ft dt. So you can just do that in your calculator. Sorry, I just realized that my limits are wrong. I read that inequality incorrectly, so let's just rub that out. Sorry, x is that's probably why it's a good idea if I drew a number line, I wouldn't have made this mistake. So x is less than 7. I read that as greater than 7. So we're actually going to go from 5 to 7. So if I drew that on a number line, so 5, 6, 7, 8, 9, 10. All right, so less than 7, we're here, and then less than 10. Okay, so what they have in common is 5 to 7. Sorry about that. All right, I'm just going to do a sneaky check the answer because I don't want to spend a lot of time doing that on the calculator. So you can see there it's approximately 0.28. Should really do it to 4 decimal places, but when you do that on the calculator, you can get it to 4 decimal places. All right, let's move on to question 6. So a probability model for the mass x kilograms of a 2-year-old child is given by, so here we've got a trig function, treated exactly the same. Show that k equals pi on 20. So we're going from 7 to 17. Okay, so let's just set up our definite integral. So we're going from 7 to 17, and our function is k sine pi x minus 7 on 10, and that's with respect to x, so dx. And because it's a probability density function, we've got to let it equal 1. Okay, so if you ever see show that, you can just set up an equation and let it equal 1 majority of the time. All right, so we're basically solving for k. So we can't go ahead and do this on our calculator. We do have to do the majority of it by hand. So let's go ahead and do the antiderivative. So we're going from 7 to 17. All right, so the antiderivative of this, all right, so we're going to have, because it's sine, so the antiderivative is going to be negative cos, and then we just take this coefficient here. So pi on 10 is going to become negative 10 on pi, k cos, and then whatever is in the brackets. So pi x minus 7, oh, running out of room, on 10, close the brackets. I probably shouldn't have put that square bracket there. All right, so let's go ahead and substitute the values in. So negative 10, that's equal to 1. Negative 10 on pi, k cos pi, substituting in 17, so 17 minus 7 over 10, minus, and then we're substituting in the 7, so negative 10 on pi, k cos, oh my gosh, this is so long, 7 minus 7 over 10. But girls, this is a good question to do, good show that. So with show that questions, you should never substitute the answer in. Okay, you've got to they've given you that answer so you can use it in part B. All right, so if we went ahead and did that, we're going to have cos pi. Now cos pi is 0 from memory. Oh my gosh, my brain is not functioning today. And then here we're also, oh no, we can't have cos 0. Let's just use the calculator. Oh my gosh, I'm not functioning the best this morning. Go on, not cos. Cos pi, I don't want to be in radian. Negative 1. Oh gosh. And then cos 0 is 1. Of course it is. Okay. All right, so we've got negative 1 here. So we're going to have negative 10 pi k times negative 1. So the cos 17 minus 7 gives you 10. So 10 pi on 10 leaves you with pi. So cos pi is negative 1. That's where that negative came from. Minus, and I'm going to put brackets around that because we've got quite a few negatives hanging around. Then we've got 7 minus 7 is 0. So all of this is going to be 0. So cos of 0 is 1. So then we've got negative 10 on pi k. And that is all equal to 1. And then we just need to solve for k. So this is going to be 10 pi k. So the negatives cancel each other out. And then we've got negative and a negative, so a plus 10 pi k equals 1. Just going to scroll down a little bit to give us a bit of space. All right, so we've got 10 pi k plus 10 pi k. So that's going to be 20 pi k equals 1. And so k is equal to 1 times pi on 20, which gives us what we wanted. All right, so we wanted to show that. So long way around, finally got there, k equals pi on 20. So part B, hence find the percentage of 2-year-old children whose mass is greater than 16 kilos and between 12 kilos and 13 kilos. Oh, sorry, question B, we're going to have to, question 8, sorry. I'm going to have to move you out of the way. Let's just move that to the next page. Okay. Gosh, such a long video. So greater than 17. So we're only going up to greater than 16. So we're only going up to 17. So we want the probability that x is greater than 16. So we're going from 16 to 17. Now our function we can now write with k. So k is pi on 20. So I'm just going to write the function there, pi on 20 sine pi x minus, got it written up there, on 7 over 10, and we want to do dx. All right, so just cross that off. All right, so you can just go ahead and do that by hand or on your calculator. All right, I'll leave you to do that one. So that was the first part. And then part 2, what have we got? Between 12 and 13 kilos. So we're just setting up the same definite integral, but we're going from 12. So it's 12 to 13. Okay. And our function, so pi on 20 sine pi x minus 7 on 10 dx. And then you can just do that by hand or on your calculator. All right, so for question 8, so a random variable has a probability density function given by, so you've got a hybrid function there, and we've got, you can see different intervals. All right, but we've also got k. Okay, so with question A, where it says sketch the graph of the probability density function, when you think about it, these are both just linear, these are, start again. These are both linear functions, okay? So if we were to expand that, so f of x equals k times 1 plus x, I get k plus kx. All right, so it's just a linear graph with a gradient of k and a y-intercept of k. So when I sketch both of them, so I might just do the other one as well. So we've got k minus kx. All right, so to sketch them in part A, do it over here. So they have a y-intercept of k. And so the first one is a positive gradient, and the second one has a negative gradient. And the x-intercept, you can just let y equal 0. So when we do that, we get -1 here and 1 here. And you can kind of see from your graph for the first equation, we're going from -1 to 0. So that's why I stop at k. And then the second one, we're going from x equals 0 to 1. So we're stopping there. And then everywhere else it's 0. So we kind of just need to draw that line on the x-axis. All right, so there's your graph. Part B, evaluate k. Now, what this is symmetrical. So the area under the graph is 1. Okay, but because it's symmetrical, we don't need to do let it equal 1. We can actually let it equal 1/2. So if I wanted to set up a definite integral, I can just use either side. All right, and because I'm a fan of positive things, let's go from 0 to 1. And that function is k minus kx. We're doing it with respect to x. And we're going to let that equal 0.5, okay, because it's just half the triangle. All right, so let's do the definite integral. So, sorry, the antiderivative. So that k becomes kx, and then negative kx becomes negative kx squared on 2. And then we're just doing it from 0 to 1 and let that equal 0.5. So I'm just going to go ahead and substitute in 1. So k minus k on 2 equals 0.5. And then you can take k out as a common factor. Let's just move question 9 down a little bit. So we get 1 minus a half. So k times 0.5 equals 0.5. So k is equal to 1. All right, so part C, we'll just do over here, all over the place. Find the probability that x lies between negative 0.5 and 0.5. So let's set up our definite integral. So because we're using two separate functions, so 0.5 is here, negative 0.5, and 0.5 is here. So the area here is the same as the area on the other side. So I don't need to go from negative 0.5 to 0.5. I can just go from 0 to 0.5 and then multiply it by 2, okay, because it's the same both sides. And then I'm only using one function, okay, so k minus kx dx, and I know what k is. I don't know why I wrote k, so let's just don't write it in terms of k. So k is 1. We did that in part B. So 1 minus x dx. And then we just go ahead and solve it. So that's quite an easy one to do. So the antiderivative of 1 is x. Then we've got 1 minus x squared on 2. And we're going from 0 to 0.5. Substituting in 0 is going to be 0. So I'm just going to substitute in a half. Now I prefer to work with fractions. So I'm going to just convert that decimal into a fraction. So we've got a half, then we've got a quarter divided by a half. So divided by half. So we're going to have half, and I've forgotten something, I'll fix that in a sec. So minus all right, I made a mistake. Let's go back. I knew I made a mistake because I'm ending up with 0 and I made the mistake here. Sorry. It's a quarter divided by 2, not by a half. Okay, so I get a half minus 1/8. Now, what I've forgotten to do is I forgot to add in this 2. So don't forget we've got to do 2 times everything. All right, so I should have that 2 times everywhere else, just to be consistent. Okay, so we've got 1/2 minus 1/8. So 1/2 written as, with the same denominator is 4 on 8 minus 1 on 8. So we've got 2 times 3 on 8, which gives us 6 on 8, which gives us 3 on 3/4. All right, so a good question to do. That wasn't too difficult. You could do the two areas separately, but sometimes when you can see it symmetrical, you can just look for one bit and multiply it by 2 or whatever you need to do. All right, let's move along to question, oh gosh, quite a few more questions to go. All right, question 9. All right, let x be a continuous random variable with a probability density function given by, sketch the graph. Okay, so that's just a parabola. I'm sure you can sketch that. Let's just move on to B. Okay, so we want to go from 0.25 to 0.75. Oh, we have to sketch it on the graph. Okay, 3x squared dx. We'll do that as well. All right, so the antiderivative of 3x squared, so that becomes increase that power over 3 over 0.25 to 0.75. So those 3's cancel out and we're just left with x cubed, which is nice. And I'm going to use fractions, so that's a quarter and this is 3/4. So we're left with 3/4 cubed minus 1/4 cubed. So that's 9. 4 cubed is 64. And then we've got minus 1 on 4 cubed, 64. So 8 on 64 is 1/8. Oops. I'm just going to check the answer. All right, made another mistake. Oops. So hopefully you picked that up. Just rub that out. Okay, so 3 cubed is not 9, it is 27. Can't believe I did that. Minus 1 is 26. And then let's just simplify that. So 13 on 32. All right, so let's sketch the graph. Actually, might be good. So it's 3x squared and we're going from 0 to 1. All right, so it's a positive parabola. Okay, so 3x squared hasn't had any transformations other than this dilation, so that's fine. So I'm just going to draw a parabola like that, and we can put 1 here. So to get this corresponding value, I'm just going to substitute 1 in. So 1 squared is 1, so that's going to be 1, 3. So if I'm graphing it, we're going from 1/4 to 3/4. So there's a half, quarter, 3/4. So this is the area we just found in here. All right, 2 more questions to go. So the weekly demand for petrol at a particular service station is a random variable with the probability density function. All right, so determine the probability that more than 1,500 litres are bought in 1 week. Okay, so we're looking at thousands of litres. So this is, I guess, from 1,000 to 2,000. So we can just keep it as 1.5, but just remember, sometimes you do need to remember the units that you're working with. Okay, so we want to know more than 1.5. So we're going from 1.5 to 2. So 2 is our maximum. And there's our function. So 2, 1 minus 1 over x squared dx. Now you could go ahead and do that by hand quite easily. All right, so you're just finding the antiderivative of that. So let's write it out again. Just expand it first. So 2 times 1 is 2 minus 2 on x squared. All right, so I might just do the antiderivative. So antiderivative of 2 is 2x. Actually, I could have taken the 2 out as a common factor. That's all good. And then minus, so this is, let me just write that as 2x to the negative 2. All right, so we're going to increase our power. So it's going to become negative 1 over negative 1. All right, I'll tidy that up in a second. So 1.5 and 2. All right, so we've got 2x, then it's going to be plus, and then 2 on x. And then we're going to 1.5. So substitute those values in. So we're going to substitute in the 2. Minus, don't know why I put that second one in brackets, 2 times 1.5 plus 2 divided by 1.5. All right, so we've got 4 plus 1, and then we've got minus, so 3 plus, so 2 divided by 1.5. I might just do that over the side. So 2 divided by 1.5 is 3 on 2. So it's 2 times 2 on 3. So that's 4 on 3. So 9, 13 on 3. Let's just change that 5 to 15 on 3. So 2/3. All right, now question B. Determine the probability that the demand for petrol in 1 week is less than 1.8 thousand litres. Oh, given that, so we've got a bit of conditional probability in this one. It is more than 1.5 thousand litres. So I'm going to set you up with just the notation, but then you can go ahead and finish it off. So what do we want? Less than 1.8. Given that it is more than 1.5. All right, so we want the probability that x is less than 1.8 and x is greater than 1.5, or just running out of room, over the probability that x is greater than 1.5. So for our numerator, we've got to be less than 1.8 but greater than 1.5. So we're going from 1.5 to 1.8. And then you can just put your function in. And that is over x is greater than 1.5. So we're going from 1.5 to 2 of f of x. And you can just go ahead and do that by hand or on your calculator. So you actually did the numerator in part A. So you only have to do the top part again. Oh no, not again, but you have to do the top part. You don't have to do the numerator. All right, question 14. A random variable x has density function given by, all right, find the probability that x is less than or equal to 0.5. So what we have here, if we think of the graph, so we've got, I might just graph it over here. Oh, that to be a different color. All right, so 0.2. is here. So we've got a straight line from, so -1, doesn't matter if it's an open circle or a closed circle. Go to there. Probably does if you're graphing it though, so I should graph it correctly. And then 0.2 plus 1.2x. So here we have a linear function. So we've got an x-intercept of 0.2 and a gradient of 1.2. So, and that goes to 1. So I'm just going to be a little bit sneaky and put 1 there. Draw my line up to 1. And the y coordinate of that, I just need to substitute 1 into here. So it's going to be 0.2 plus 1.2. So that's going to be 1.4. Let me just go up a bit. Oh, not very accurate scale, but anyway, 1.4. And then everywhere else it's 0. So when we're greater than, sorry, less than -1, it's 0, and it should be a closed circle, and this is an open circle. All right, so there's our graph. I know we didn't have to graph it, but sometimes it's a good idea to see, visually what it's asking for, especially when you've got multiple functions. So find the probability that x is less than 0.5. So 0.5 is here, so 0.5, and we want less than that. So you can actually see we've got this area here, all right, is a rectangle. Okay, so we can, for part A, we can do that rectangle plus just this area on the other side. So I might highlight that in a different color, plus this. So we can use a definite integral for that, but the rectangle, we will just use our values, which is a little bit easier. So 0 to 0.5, and where our function is 0.2 plus 1.2x dx. So what we could have done actually is done 1 minus what we didn't want. That would have probably been an easier way. Okay, so we're going, so a rectangle is 1 times 0.2. Okay, so 1 across, 0.2 up, and then we've got our definite integral. So I'm just going to find the antiderivative. So 0.2x plus 1.2x squared over 2, and we're going from 0 to 0.5. So 1 times 0.2 is 0.2. All right, don't need to substitute in 0, so I'm just going to substitute in 0.5. Now, if it's easier, work with fractions, but 0.2 times 0.5, so 2 times 5 is 10. So it's going to be 0.1. And then plus 1.2, 0.5 squared over 2. So I can add them together, 0.3. 0.5 squared is 1.2 times 0.5 squared is 0.25. Yeah, definitely easier to do with fractions, but anyway. Testing my knowledge of decimals. So 1.2 times 0.25. Oh my gosh. All right, so 1.2 as a fraction is 6 over 5. I'm just going to convert it into fractions. All right, so 6 over 1, 2, 3. And 3 over 20 is the same as 0.5. All right, so that question is a good test of decimals, but if you can easily convert into fractions, I just find fractions so much easier than decimals. Okay, so that was the area under there. You could have also done 1 minus the area that we didn't want, which in hindsight may have been a bit easier, but it wasn't too hard what we just did. Okay, so 1 minus this green area if we wanted to. All right, so for part B, we've got conditional probability formula. So find the probability that x is greater than 0.5. So greater than 0.5, given that x is greater than 0.1. Oh, come on. I'll just use green. Okay, so we want the probability. Okay, so what do they have in common? We've got greater than 0.5 and greater than 0.1. So we've got x has to be greater than 0.5. That's what they've got in common over the probability that x is greater than 0.1. Now, what we did in the previous question, we found out the area that was less than 0.5. So that means this area, this green section, is going to be 1 minus 0.45. And then x is greater than 0.1. We're going to go from 0.1 to 1. And then that's our function, 0.2. plus 1.2x dx. All right. Oh, I'm running out of room. Okay, so you can do the denominator on your calculator. So 1 minus 0.45 is 0.55. And then the denominator, let's just quickly do it on the calculator just to finish the video. Okay, let's get a definite integral up. You can do this by hand as well. We kind of did some of it in the previous question. So 0.1, 1, and it's going from 0.2 plus 1.2x, and I didn't put, and then we've got dx. .774, and then let's just finish that off on the calculator. So we've got 0.55 divided by 0.774. So we've got 7106. So that question would have been good to do by hand, but yeah, we're running out of room, and also this video is taking forever. So I would actually try B by hand, okay? It's good practice of your decimals and fractions to do questions like this by hand. But anyway, I'm going to stop there because it was an extremely long video. All right, bye girls.